Hello, and thank you actually very much for the invitation. Slide says it. My name is Tim Ward. I am actually, unfortunately for me, now the Associate Director of Telecommunications at Northwestern University. I used to be an engineer, and in fact I was quite interested in seeing the security panel up here because I believe at the last NANOG in Dearborn, which was the last one I had attended before this, a very similar discussion took place. It was actually kind of surprising to see how far we haven't progressed in those years. But we will do better, I am sure. What I'm going to present to you today is actually a quick overview of a joint actually production service that we actually have in service at Northwestern University, a joint project between a number of people in network engineering, a number of people in user support, and a company actually out of Libertyville, Illinois called Video Furnace, and I'm going to try and make that the last commercial for them. Just so you know, though, when I refer to we, I'm really referring to those groups in this talk. Video Furnace providing the hardware and the software, network engineering providing the network, and user support helping the users. All right. So, what exactly have we done at Northwestern University? We have deployed actually two different services that rely on the same base technology underneath it. The first one is something we call the NUTV service. Actually, our students have a different name for it. They call it the NUTV service. The URL for it is there. You can actually get to that page if you want to. You just can't watch TV from it. But the students can. And the TV that they get to watch are 23 channels of entertainment television, which we use as a combination of off-air and cable TV channels. We IP multicast this from the center of our network out to all of the undergraduate dormitories, which in our case turns out to be 4,350 unique locations. It's all software-based MPEG-2 encoding, full frame rate, 29.97. And it turns out that each of these 23 channels is about a 2 megabit per second stream, and we actually use 128 kilobit mono audio. Turns out that the signal that we get from the cable company more often than not is mono anyway, even for MTV. So as a result, there wasn't much point in trying to ship out stereo because no matter how you were listening to it, you were getting mono anyway. Another service that we offer to all of Internet 2 is the Internet 2 multicast service. We needed a name, and that's the best I could come up with at the time. This is actually two channels, C-SPAN and C-SPAN 2. That is actually licensed directly from NCSC, the people who hold the content licenses for the C-SPAN content. And that's, again, also MPEG-2 encoding. C-SPAN we encode at 2 megabits per second, and because we want to call it research, we encode C-SPAN 2 at 4 megabits per second. Those of you who really love C-SPAN realize that that means that the senators essentially take up twice as much bandwidth as the congressmen do. What is interesting about this project, right? I mean, okay, so far all these described as sort of high bandwidth webcasting stuff. When we first were looking at how to solve a problem that we had, getting TV into the dormitories, a big pushback came from user support services. They did not want to be responsible for supporting a client running on people's desktops. You know, so they didn't want to look at anything that used Windows Media Player. They didn't want us to be looking at anything that used QuickTime, because when you look at those types of products, you have to keep that version of software maintained, you have to keep the codecs maintained, and you have to keep the students happy. And let me tell you, one thing that we've learned is that if the students can't get their TV, they are not very happy. So we were looking for a solution initially that used hardware encoding a la vBrick, Ncast, Minerva, Optibase. But those companies actually didn't have a particularly robust client-side software-based decoding. The whole expectation that we had when we were planning out the service is that the students would be watching TV on their computers. I know, wacky idea, but have you seen their dorm rooms? I mean, they're like tiny, so if you don't have to put a TV in it, that's actually a good thing. And the other thing that some of these other competing products that we looked at had lacked was the whole concept of a channel guide. And this gets back to the main point of what we rolled out. We're rolling out not pedagogically important television. We're not rolling out, instructional television. We're not rolling out Spanish class. We're rolling out TV, plain and simple. Entertainment quality, or lack thereof, depending on what you like to watch. And so when you're rolling out an entertainment service, you really need to have a channel guide. And that was something that we thought originally we could just go ahead and put that together, right? 20, 23 channels, not a big deal. It turns out though, we just didn't want to be involved in that. And that was something that our partner decided that they could actually work on and sell as part of the service. Why do we deploy this type of service? Well, these are the official reasons. The real reason we deployed it is I like IP multicast. And I've been working on IP multicast for probably 5 or 6 years on the campus, including some really ugly versions of beta code for 7513s that would allow it to actually do wide area multicast. So you could argue that I was simply looking for a problem for a really nice solution. The official story, however, is that we don't have cable television in our student dorm rooms. We only have it in the common areas and the lounges, and as our student affairs division converts common areas and lounges into doubles, triples, and quads for more and more students, there are fewer and fewer places to watch television. And we actually have over 60 residence halls. Our campus actually is about 13 miles north of here in Evanston. And in Evanston, we have this building height regulation. Our buildings can't be taller than 4 stories. So we have a lot of small, wide dormitories. So the cost to wire these things is actually exceedingly high. You talk to the cable company, it's $2 million, $1 to $2 million. If you do it what I would call the right way, it would probably be about $5 million. And then it would take about 4 years to finish it. So if you're a freshman starting this year at Northwestern University and we announced the cable television package, well, chances are you're not going to get to watch TV by the time you graduate. Now, you wouldn't think this would be a big deal, right? We obviously had some administration backing for not having any cable TV. Our Vice President for Student Affairs many years ago was very fond of saying, well, you don't go to Northwestern University to watch TV. Go out, get involved in clubs, get involved in programs, do stuff. And so we figured we were protected. We didn't have a problem with not having TV. She retired. And the next guy came in and he said, we gotta have TV, we gotta have it now. The students really, really wanted it. It had become one of these issues that gets checked off on those little evaluation forms for institutions at the end of the year. So institutional, from not needing to do anything to an institutional prerogative almost overnight. Quick idea of what the system looks like. I'm doing this a little fast because the really neat part is that through the hard work of the folks at the back table, we can actually watch the C-SPAN channels here today. So, seeing is believing kind of thing. So I'll go through this. Essentially what we've got are 23 tuners in a rack, 23 Dell 1650 servers in a rack. Those plug into the campus IP multicast network. We have a little bit of a encoder management system in place to take care of the Dell 1650s running Linux that are doing the encoding. We have the program guide server that's also connected to that network, and then we have the viewers. And again, like I said, this is all software-based viewing. The really nice thing about it is the client actually never gets downloaded onto the hard disk of the local machine. Okay? What happens is the students go to the web page, they click Watch TV, and you'll see me do this in a little bit. A small Java, actually this is a small Java application runs that all it does is tell the server what operating system the student has. And that way the server can then ship to that machine a Mac OS X binary, a Linux binary, or a Windows of any flavor binary that's about 280 kilobytes. So very, very tiny, small footprint viewer that also contains the program guide information. And like I said, we have that, that client that gets shipped out. They watch TV, they click the X button, the thing's gone. Why is this important to us? Well, it became really obvious when we started rolling this service out that, well, we made some mistakes in how we actually wanted the client to operate. And so we had to change some things, and I'll tell you more about those later. And so the fact that once the students were done viewing for the night, they hit X and didn't save the client was gone. When they went to watch it again, they'd get the new one that had the improved fixes in it. So And actually, I have a note there that says set-top box. That actually wasn't a requirement in the initial rollout, but we are actually looking at a set-top box type arrangement to just plug into a regular TV. Live encoding of television, blah, 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 blah. Sorry about the advertisement. Program guide, content labeling, good. I did all that. What did we do? We've actually had this service running since the fall of 2002 as a production service. Prior to that, in the spring of 2002, we ran a test phase, which is where I learned that it is very important to be careful when one takes multicast from being an interesting toy to a production service, because, well, I had 2 different RPs for the same group, and they didn't know about each other. So half of the campus could watch TV, and the other half couldn't. Of course, it mattered which channel they were trying to watch, too. My boneheaded mistake, luckily engineers brighter than I caught it, fixed it, took care of it. We went through a deployment phase where we learned that getting IGMP and CGMP to work together is not particularly a fun thing. The whole way that IGMP snooping works with its IGMP proxy function really sort of breaks the way CGMP has to work. As a result, what would happen is people would be watching one channel and then they'd start getting traffic for all these other channels too when somebody else stopped watching them. Which, you know, most of the time wasn't a problem until the switch killed over because it was trying to deal with too much traffic all at once. And then IP multicast, TTL threshold. I didn't point out, our network is a fairly homogeneous Cisco network, but it's not really all that substantially different in terms of speeds and feeds than most campus networks are today. We just happen, I would have preferred to be using some kind of IGMP snooping, but the generation of switches that we put in place, they only supported CGMP, and of course the students had to have their MTV. So what do they watch? We actually wrote a little expect script that goes out and grabs the layer 2 join information from all of the switches. It's really gross, it's really disgusting, it actually works. And so we can produce wonderful graphs like this. The different colors are the different, what is it, about 10 of the different channels that we have available. And you can go in and you can see week 3 of the year, so 3rd week of January on ABC on Sunday. What's everybody watching? It's about 1,000 viewers. Anybody know what's on that time of year? It's the Super Bowl. That's right. Everybody watches the Super Bowl. Well, at least 1,000 people at one time were watching the Super Bowl. And it turns out one thing that we learned is that in the student population, there are really, you know, the 3 big channels that you have to have seem to be ESPN, WB, and Fox. Students don't watch CBS. They don't watch NBC. They watch ABC, but that's only on Monday nights. So a little more information. How much have we seen watched? This is actually a graph showing a number of users over the year since October. So you can see this dip right at December. That's when they all go on break, and so nobody's allowed in the dorms, so there's nobody watching TV. Then we have March, where they all go on break again. And you can see we were hovering around 2,000, but you notice we hit 2,700 simultaneous viewers about the 3rd week of May. Anybody here want to guess what the 3rd week of May is? Sweeps week. So actually, the reason I don't break this out by channel is that no one channel actually shows up as the majority of the signal in that spike. It turns out that I think it was NBA Finals, Dawson's Creek's final episode, and one other show that I honestly can't remember. Although I am kind of amazed. I mean, we actually have to monitor the service during the day, and I know there's nothing on TV during the day, except at 5 o'clock. In Chicago, we do a lot of network monitoring at 5 o'clock using this service because The Simpsons are on. Students come back in September for us, and you can see right when they got back to campus, we hit 700 viewers within the 1st week. All right, I got 5 minutes left. How do we keep this secure, which is what this whole talk is supposed to be about? We do it in lots and lots of different ways. One of the things that we are not interested in becoming is a poster child for the RAAA. So as a result, we have access control on the network. It basically says, can this network even get to the servers that allow the machine to get the client? That's one benefit of not having the client resident. If I can control if you can get the client in the first place, then I have a layer of security that you have to break through to get it. We use multicast boundary statements, so we have all of these channels in a particular well-identified set of groups, multicast groups, that we only allow onto these 4,350, end ports. Then there's a whole set, so those two items are actually in the network. Then there's a whole set of client-to-server issues in terms of having an encrypted transaction between the client that gets downloaded and the server, operating both as a backup to the unicast network control that's in place and as a keep alive. So for example, if you decided that you were going to save the client to your machine, the server would expire your client at some point if it hadn't heard from you. And so you would go to use that client again after you rebooted your machine, moved to a different network, what have you. And lo and behold, the server would say, sorry, your client's out of date, got to get a new one. And then the streams themselves are actually encrypted as well. So even if you decided that you wanted to write a little application that was going to strip off the proprietary headers that everybody puts on their MPEG-2 packets, multicast packets on the network, that stream itself is actually encrypted as well. So yeah, not much worth watching. This turns out to be very important when you go to talk to a cable company. That's how we actually get licensed to do this content. To get them to treat us as a multi-dwelling unit, because they want you to pay by the drop. That's how come I know it's 4,350 unique locations, because that's what's on the bill every month. So C-SPAN, C-SPAN 2, like I said, slightly different. We have a limited right to retransmit from the content owners themselves. So sort of two different ways of getting licensed to get content. Obviously, it's MPEG-2, so we have the whole issue of actually being able to pay royalties to people who wrote the MPEG-2 algorithms. So we well provision that for the student television. I think it's about 4,500 because, like I said, the network engineers actually have to be able to monitor the service, right? So, of course, they get to watch TV all day long. In fact, we have a mysterious server 21, which is sort of our test server. Strange, that's always like tuned into White Sox games because we don't get the channel they're normally on. And then for the Internet 2-based distribution of C-SPAN and C-SPAN 2, we actually over-provision the number of licenses we need and keep an eye on that. And this last point is the what's missing from the player, which links which you can look up online. I think I've been through most of them already. This is what that looks like, but far more interesting will be to get out of the presentation itself. That's okay. We won't send. Far more interesting usually is to get out of to reboot the computer. Leave it to Windows. See, I knew I should have been running the Linux client for this crowd. Interesting enough, we do know the distribution of our viewers and our users on campus. Hopefully this thing will reboot sometime soon. We'll let it figure it out as it goes. And it turns out that the vast majority of our students are, it's just the other laptop. The vast majority of our students actually are Windows users. I hang my head in shame. No, that's it's the platform of choice at our particular educational institution. But we did realize the institutional imperative of actually having Mac and Linux clients. Does anybody know how to make Windows boot faster? Let's see. Why don't we take some questions and then I'll do the demo. Or I could tell you what's missing from the player. Are you all dying to know what's missing from the player? What's missing from the player is there's no record button. So the students they don't actually have right now a PVR type functionality built into the viewer that they use. Hey, look, I can type my password for everyone. Luckily, it's not one I use for anything else other than this machine. Well, that's okay. Oh, yeah. Yeah, the question was what actually was the distribution, and I got distracted there and didn't tell you what it was. I think it was 95% Windows users, about 4% Mac users, and about 1% Linux users. Clearly, we need some harder core engineering students, I think. But actually, a good question. The question was whether or not this goes to the entire campus. It turns out that most of our about half of our ports on campus, and we have about 20,000 of them, are still on shared infrastructure. So we're in the process of a rebuild. Oh, excellent. We're in the process of a rebuild to take care of that. Luckily, in the dormitories, we did that rebuild about 2 years ago. So the other thing I should point out is that the wiring in the dormitories is nothing special. It's they're all on switch 10 megabit connections. One of our previous engineers actually referred to the wiring that we use there as category nothing wiring, because in our infinite wisdom, we started out by breaking my computer. Did I go to the right one? I'm not sure I was shipping out video. You ready?
Try again. No?
Hold on.
Is the other one A or B?
It should be on B. I'm the black one. No. Not the black one. There we go. It's always important to trace the cables. Here we go. Now you'd think I'd be able to show the display here and show it up there at the same time, and it works for everything except for video overlays, which is how the whole system works. So I have to make myself blind here for the moment. And so a little license agreement that says I'll work and play well with others. I won't run with scissors and I won't steal things. And what's happening right now is you see Java just loaded on my machine. You got the little icon down there. And we have the little security to actually run the Java application. And there's the client. The data in the program guide actually gets streamed to you via multicast as well. We're tuned in by default on this to C-SPAN. It looks like they're actually talking about something in Congress today. I guess I could turn up the volume.
It's not above our strength.
Everybody hear that?
Pains and toils are not beyond our endurance.
Okay, so this is Congress, this is the 2 megabit stream, this is the equivalent of what the students are actually seeing. You'll notice some of the features in here.
Once again, ambushed but
First of all, there's keyboard shortcuts for everything, like mute. I usually do the audio and then just don't worry about it. Keyboard shortcuts for everything, because the students discovered that you could go out and buy a remote that plugs into your USB port, and you could change the channels and change the volume. And they thought this was really, really cool. But the other thing was, well, what about if I wanted to say, watch 2 channels at once? And it turns out that the limitation there is strictly your machine. I can actually, on this machine, over the network, usually watch 4 of the 2 megabit per second channels at one time. I don't understand what's happening on 3 of them, because my brain is not wired that way. Apparently, we do have students who watch 2 of them all at the same time. Let me run through here. And we should have the second client come up.
You have now attacked our own safety. You shall go no further.
And one of the things that the students didn't get when we first did
cases in which states in which abortion was legal,
they were essentially
1942
sensitized
would have been no
to
death.
internet video in this little tiny screen like you see over on the side here. And so they were like, oh, quality's very good. We really like this. The program guide's neat. How do I make the picture bigger? And of course, we all had been working with this for about 2 months, and we were like, what do you mean, how do you make the picture bigger? Make the picture bigger. It's not that hard. You can click on the TV button, which is one of the first changes that we had to make, was to actually put the TV button in there. And then, 2 channels at once, 2 channels at once, 4 channels at once. Large size. You can even take this up to full screen. I'm going to get rid of this one. Sorry, I should drive from this monitor and then my voice will carry. We can even take this to full screen. So again, this is the 4 megabit per second stream. You might ask, a good question to ask me is, why are we doing 1 at 2 and 1 at 4? And, or why are we doing all the student channels just at 2, right? I mean, seems kind of silly. It turns out that that decision was entirely based on what we told last year's seniors to buy when they came to the university as freshmen, which I think was a P2 300. And so we figured that if we're rolling out a television service to students, we really ought to roll out something that they can actually at least watch 1 channel of. After all, these are, our future donors, so we have to do something nice for them. This year, actually, we had intended on taking the standard streams for all of the NUTV service up to 3 megabits per second, which is just a little bit less than this, because there actually is a fairly significant quality improvement when we do that. Well, all of my network engineering staff got kind of busy when the students came back to campus with all of those infected laptops. So we weren't able to make any of the changes. We're hoping actually that we'll take the student service up to 3 megabits this coming December. But that's actually about all I have for prepared remarks, but if you have any questions, I would be happy to take them.
We can take maybe a couple, question or two, if anybody has one.
Tony Capella, Service Central. Question about the encoder systems. I don't know if you've mentioned it on your fact yet, since I have no laptop to read it with, but you mentioned on there what encoding software you're using to actually sample the video and create the string?
Actually, that's part of the partnership that Video Furnace deals with. So, as much as I know about that, initially we were using a set of Osprey 100 and capture cards with their proprietary software for actually, or with Video Furnace's software for actually doing the actual encoding.
But the binary is on Linux nonetheless.
Exactly. The servers are all run on Linux.
Thank you.
Mm-hmm.
Bruce Campbell, NCC. Trying to think how to formulate my question. What do you think, have you used this for broadcasting events, say like a NANOG or a Write meeting to students, or maybe a broader base? Or have you thought about that?
Actually, we've thought an awful lot about that. Yeah, I didn't point it out because I was going kind of fast, but in the screenshot for the demo, there was this big yellow and white thing up in one corner. That's actually what we affectionately refer to as NU Channel 1. And right now, NU Channel 1 is the bane of my existence, the calendar of events. Just like everybody sees. The intent, though, is to take content from our School of Journalism or content from our School of Communication and have them be able to interrupt the calendar of events and show the Northwestern Nightly News, which is actually part of a curriculum at the school for producing a live news broadcast that up until this point has never been broadcast live. So there is the intent to be able to take live events, dump them in, with encoding systems that are anywhere on the campus that can then populate guide data at some centralized guide. So another example for the C-SPAN portal would be, well, wouldn't it be cool if we could take BBC, we could take the equivalent public affairs programming from France, Germany, Japan, have them all be encoded from wherever their respective countries are, assuming they all speak multicast. Right, David?
Right.
And they all do.
And English.
And then just have them all appear in each other's portals, so you could just go through, and if you decided you wanted to actually watch, what happened in the House of Commons, or whatever the equivalent is on, on the BBC, you could. Of course, if you're on internet too, because that's the way our license is written.
Okay. Leo Bicknell with AboveNet. Does the system support closed captioning? And if not, is that a problem for you?
Excellent question. The system as it stands right now does not support closed captioning. However, there's always a however, that is actually planned for the next release of the software, which we're hoping will come out this fall. Our Student Affairs Division, who is the organization we did this in cooperation with, decided that they did not want closed captioning to be a holdup for everything else, so that if we actually had a student on campus that required closed captioning, they would go ahead and we would work with them to figure out how to get regular cable TV to them. It turns out we actually have to change the encoding card out to get a good enough decoding on that extra on those lines in order to be able to ship out the closed captioning. But the whole idea is to actually have client-controlled closed captioning display.
Dino from Procket. I came in a little late, but are you using SSM or planning on transitioning to PIM SSM?
Oh, another excellent question. If my 3500 supported, IGMP version 3, I might think about it. Because you're exactly right. This is a tailor-made application for SSM because it's all, there's no, backwards feedback on this at all. But my infrastructure isn't in a state that it can actually support that. So that would be the kind of thing that we would look at transitioning, maybe an additional portal for the C-SPAN services, maybe at yet a higher bit rate with MPEG-4 encoding using SSM. So, is that it? No more questions? I could bore you to death with the Senate, but I won't. Thank you very much.
Thanks, Tim.